This is section 6.5, operations with matrices. And we're going to do these sections a little out of order. We'll start with 6.5 and then we'll go back to 6.3 because of the way I'm going to teach it. And then we have two other sections. These are very quick sections as far probably as your homework. It's pretty much calculator work for a good portion. So just have your calculator ready. And there are some matrices notes in the handouts, and I've put one in this lecture note part 2, which is just a kind of cookbook how to do some things. So that's available to you as well. So let's start out and talk about what a matrix is. It's simply a rectangular array of numbers, and you see it usually with the brackets like you see here. We talk about the rows and the columns, and we talk about the size of a matrix by this designation. It's row by column. So this is a 2 by 2, this is a 2 by 3. You need to know that for when you put them in the calculator. It will ask you the size, and remember it's always row by column. When you are adding or subtracting, the matrices must be exactly the same size because you have to add or subtract the elements in the same position. All right, so if you were asked to add these two, they are exactly the same size, and we're going to add the ones in the same position. So 1 and -3 would give us -2, 3 and 0 would be 3, 9 and 2 would be 11, and -4 and 7 would be 3, and that would be our answer. You could do those on the calculator, but I think you can do them as quickly by hand, so I wouldn't fool with that on the calculator, but you could. Multiplying by a scalar is going to be a number outside the matrix. So if you were given this is matrix A and you wanted to know what 3A was, you simply multiply 3 times every element in there. So we would have 3 times 1, 3 times 4, 3 times -7, and 3 times 2. And that would be our answer for that. Now, for multiplying matrices, you are going to use your calculator. There is a rule that you have to think about because sometimes it's not even possible to multiply matrices. They do not have to be the same size. The number of columns in the first one has to equal the number of rows in the second one. So the easiest way is to write down the size of the first one, size of the second one. Okay? The columns in the first one has to equal the rows in the second one. If those two numbers are the same, then you can multiply. The outside numbers, 2 by 1, tell you what size your answer will be. So this 2 by 3 times this 3 by 1 is going to equal 2 rows, 1 column. Now, how are we going to do that? Let's get the calculator up here. We're going to go to second, and matrix is above the X inverse key. So right here, and I'll say second matrix. You have 3 menu items, names, math, edit. We'll go over to edit and hit enter. All right, now this size 3 by 4 is already there, and you can just type over it. So I'm going to put a 2 by 3, 2, enter, 3, enter. All right, it gives me a 2 by 3. I can just type over these numbers. So I've got 3, 5, -1, and it pops down. So 6, 0, 4. All right, and once you've got it, second, quit. Now let's repeat that process and create this second one. Second matrix, over to edit. We want to come down to the second one, so come down before you hit enter. We'll hit enter, and we do have a 3 by 1, and actually those numbers are already in there. So 5, 8, 2. I'm going to second quit. All right, when you've got everything in that you want to work with, we're going to just say we want to multiply A times B. So I'm going to go back to second matrix, I'm going to, on the names column, I want to say enter so that I get A, multiply sign, go back in, go down to B, enter, and you've got A times B equals, hit enter. 5338 is your matrix answer, and it did in reality turn out to be a 2 by 1. All right, so we're going to do enough practice that you should be fine with this. So let's go to our problems. Sorry. Okay. If possible, find values for x so that matrices A and B are equal. Well, all that means is if these things are equal matrices, then the individual positions must be the same. So here's an x, here's a -1. So that means that value has to be -1. Y has to be 0. Pretty simple on that. Find each of the following. All right, A plus B. So here's your A, here's your B. We're going to simply add the items. So you're going to have 9 minus 7, 5 minus 6. Okay, so we're going to have, I'm going to put the matrix out here so that we can see it. So we've got a 2, 5 minus 6, -1, -2 and a -5 is -7, 4 minus 7, -3, 8 and a -9 is a -1, and -7 and 9 is 2. And you would put those numbers in the boxes in your matrix. All right, 8A. We're just going to multiply 8 times every number in here. All right, and so we're going to have 72, 40, -16, 32, 64, and -56. I was multiplying 8 by each of those. All right. And this one says 9A minus 6B. So here's what I would suggest to do. First of all, I would do 9A equals. All right, that means I'm going to multiply 9 times all of these. All right, so we would get 81, 45, -18, 36, 72, and a -63. Then we need 6B. 6B equals. So we're going to multiply 6 times these numbers. All right. Oops. All right, so we would have -42, -36, -30, -42, -54, and 54. All right, so that would be that. All right, now we're going to subtract these two matrices. So when we do that, we should get, you'll have 81 minus a -42. And we should have 123 and 81 would be this one. All right, and then we have a 12. I made that too big. 12, 78, 126, and a -117. Okay, and so you're just subtracting this, subtract that, that minus that, that minus that, etc., all the way down, and that would get your answer. All right, let's give ourselves a little bit of room here. All right, number 3, we're supposed to multiply 2 times this and subtract 3 times that. So if I multiply 2 times this one, I would have 10, 8, -6, 12, minus 3 times this one. I'm going to have a -18, 3, 21, -6. And then when I do the subtraction, 10 minus a negative 18, 28, 5, negative 27, and 18. So that'll be your answer for that one. All right. Same thing with number 4. We're going to multiply 4 times these, and we'd have 16, 32, 4, 36, minus 3 of these. So I'm going to multiply 3 by these numbers. Okay. And when you subtract those, then you would have negative 8, 11, negative 23, and 42. Okay. All right, let's make this guy a little bit bigger and give ourselves some room. All right, if possible, multiply A times B and B times A. All right, so let's see. They're 2 by 2. They're each 2 by 2, which means, yes, we can multiply both ways. So let's put these in the calculator. Second matrix, and we're going to go over to edit. And for A, I'm going to edit it, and I'm going to have a 2 by 2. Enter. And then I'm going to have a negative 3, negative 3, negative 4, negative 4. All right, and then I'm going to second quit out of that, and then I'm going to go back in and go back to edit and down to B and enter, and I'm going to have a 2 by 2 again, and I'm going to have a negative 5, negative 6, negative 5, negative 5. All right, I'm going to quit. So every time you create one, you go ahead and quit out of it. All right, so now I want to do A times B. So second matrix, grab A, times second matrix, grab B, and enter. And so this 30, 33, 40, 44 would be my answer here. 30, 33, 40, 44. All right, now we can go right back in, second matrix, grab B first, times second matrix A, and enter. And you note you don't get the same thing. In real numbers, in our real number system, multiplication is what they call commutative. It means A times B is the same as B times A. In other words, 2 times 3, you get 6. 3 times 2, you still get 6. But with matrices, that is not necessarily the case. So we can't assume we would get the same number. We see that here. So we have a 39, 39, 35, 35. All right. Let's come down to number 6. Same kind of problem. Can we do the multiplication? This is a 2 by 2. This is a 3 by 1. All right, and remember we're looking at these two numbers. They have to be the same in order for this problem to even be possible. So for the first one, A times B, it's not possible. And for the second one, we would have the same thing. You'd have a 3 by 1 and a 2, what was it? 3 by 1 and 2 by 2. And you still don't have, you still don't have the same numbers here. So this one is impossible too. Okay, all right, let's go to number 7. All right, those are both 3 by 3s. So those should be possible to do. And if we go, we'll do one more of these. Second matrix, over to edit, and enter. And this is going to be a 3 by 3. All right, I'm going to put in -2, 0, 4, and then -3, 3, 3, and then -1, 4, -3. Second, quit. I'm going to go back in, go over to edit, down to B, enter, 3 by 3. Put those numbers in, -5, -1, 4, -4, 1, 2, -4, 1, 5. All right, then we'll second quit, and we want to go back in, grab A, times, go back in, grab B, and enter. And that will be our answer. Let's see if I can. Oh, it put it down there. Let me see. Try to fool with something here. Not going to let me do that. Okay. All right, I'll just write the numbers. So for this part, we had -6, 6, 12, -9, 9, 9, 1, 2, -11. Okay, so we did get that. All right, and then we're going to go back in, second matrix, grab B, times second matrix, A, and enter. We totally got different numbers. Let's write those here. We got 9, -13, 35, 3, 11, -19, 0, 23, -28. Number 8 is the same kind of problem. They are 2 by 2s, and rather than me do those completely here and the time, I'm just going to put the answer because you can look back at the other problems for the process if you don't remember. But here's what you should get. And for B times A, -56, 52, 17, -7. All right. Number 9. We have a 2 by 3 and a 2 by 3. And what do we notice? Those numbers are not the same. So this is not possible, even though they were the same size. The others, when we saw that they were square matrices, in other words, 2 by 2 or 3 by 3, then we knew it was okay because all the numbers were the same. But in this one, it's definitely not possible. All right, in number 10, we have a 3 by 2 and a 2 by 3. So we're good there. We know that that's possible to do that way. All right, and again, I'm going to put the answer for you because we've done several of those. All right, and then B times A we could also do. And so we would have -22, 11, 47, -24. Number 11. All right, let's look at what we've got. We've got a 3 by 3, and we've got a 2 by 3. So for A times B, that is not possible. What about B times A? So we would have a 2 by 3 and a 3 by 3. So on that one, we're good. So if you can go ahead and do that matrix, you would put you would have A and B in, and you would just be sure to do B times A, and you would get, give myself some room here, you would get -7, 0, 22, 13, -3, -37. And remember, your 2 by 3, that outside set of numbers tells you your size of your answer. All right, number 12, we can do this one. Remember, we've got a 3 by 3 and a 3 by 1. So for A times B, we can do that. And that's going to be a 2, 11, and a 12. But B times A, we've got 3 by 1 and 3 by 3. Those numbers aren't the same, so this matrix does not exist. 13, using a graphing calculator to do this one. So let's go ahead and do this one because it is a little bit different. Let's go ahead, second quit, clear, and I'm going to pause just a minute and get those in the calculator, the numbers, just so I don't take up all that time, and then we'll start right back up. Okay, so I have gone into second matrix and put this in as a 3 by 3 and this in as a 3 by 3 for B. And so now all I've got to do is write this statement on the screen. So I've got 3. I want to go to second matrix, grab the name A, squared, so I can just hit my x squared key, plus 5, go back and get second matrix B, and hit enter. So if you'll note, this statement I've got on the calculator matches what we're supposed to do. I hit enter, and I get my matrix there. So let's see if I can pull that down there. All right. I can do that because I had room. So these are the answers for you. 47, -90, -33, etc. So that's all you need to do. You're putting them in exactly the same way. You just are going to type that in your calculation screen. So that should get you through 6-5, and you should be pretty familiar with operations on matrices.